Welcome to this lesson on mole conversions. Today, we'll learn how to convert between particles, moles, and grams. This is a fundamental skill in chemistry that you'll use throughout your studies in stoichiometry. Let's start with the basics. A mole is a counting unit in chemistry, similar to how a dozen represents 12 items. 1 mole represents exactly 6.022 times 10 to the 23rd particles of a substance. These particles could be atoms, molecules, ions, or any other chemical entities. This extremely large number allows us to work with manageable quantities in the lab while dealing with the incredibly tiny atoms and molecules. The number 6.022 times 10 to the 23rd is called Avogadro's number, represented by the symbol n subscript. Its value is 6.022 times 10 to the 23rd, and the units are particles per mole. This constant is named after the Italian scientist Amedeo Avogadro and serves as the bridge between the microscopic world of atoms and the macroscopic world we can measure. To master mole conversions, think of 3 interconnected quantities: particles, moles, and grams. Particles refer to the actual atoms or molecules. Moles represent the amount of substance, and grams measure the mass. You can convert between any 2 of these quantities using the appropriate conversion factors. Understanding these relationships is the key to solving stoichiometry problems. To convert from particles to moles, you divide the number of particles by Avogadro's number. The formula is particles divided by 6.022 times 10 to the 23rd equals moles. This makes sense because if 1 mole contains 6.022 times 10 to the 23rd particles, then dividing your particle count by this number tells you how many moles you have. To convert from moles to grams, you multiply the number of moles by the molar mass of the substance. The formula is moles times molar mass equals grams. The molar mass is found on the periodic table and represents the mass of 1 mole of that element or compound in grams. This conversion connects the amount of substance to its actual measurable mass. Let's work through a complete example. How many grams are in 3.01 times 10 to the 24th atoms of carbon? To solve this, we need 2 steps. First, we'll convert atoms to moles. Then, we'll convert moles to grams. This 2-step process demonstrates how to move through our conversion triangle. Here's the solution. First, divide 3.01 times 10 to the 24th atoms by 6.022 times 10 to the 23rd to get 5.0 moles. Next, multiply 5.0 moles by the molar mass of carbon, which is 12.01 grams per mole, to get 60.05 grams. Therefore, the answer is 60.05 grams of carbon. This problem shows how we can start with individual atoms and end with a measurable mass using mole conversions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.